Hello, 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 everybody. I hope you're all doing well. We're looking at our 2013 open paper, and we are on the last of the short answer questions with B4. Let A be the largest real value of x, for which x cubed minus 8x squared minus 2x plus 3 equals 0. Determine the integer closest to A squared. Okay. Just because it's B4, I'm inclined to believe this won't factor nicely. Now, it's a cubic, and all cubics cross the x-axis at least once. So they could be saying the largest real value, but they really only mean one real value. So there's lots of options. We could have that. We could also have sort of a nice little double root where it just touches, or we could have three roots. It's kind of hard to tell with this situation, and we want to determine the closest integer to A squared, not just A. Alright, so we're talking about roots. I don't know much about them, but we can try and learn more about them. Now, if I have a cubic, a monic cubic they tend to be called because there's no leading coefficient, and I expand this out and group like terms, I'll get this nice relationship. So A, B, and C are the roots. Ordinarily, I'd probably use P, Q, R, but they gave us an A, so it seems natural to go A, B, C. It'll be plus A, B. So we get these nice, called symmetric expressions. Minus ABC. So these nice relationships between the various roots. And you can see that exactly one of them involves multiplying all three of them together, another one involves multiplying pairs together, and another one involves them just being singled by themselves. If you haven't looked at things like this, I would really recommend you do it. And, add in some extra roots and see what patterns you notice. They're kind of cool to look at. If you got some spare time, they're kind of interesting. And you can also, I remember there was a very old, I think it was an open paper, but way, way, way back when. It might even actually have been an old invitational paper, or maybe a Euclid, that involved manipulating these roots just right. And you can actually, using the coefficients, so there's a nice way to match up the coefficients here. There's 8x squared, I think it was plus 2x minus 3 or something like that. But you can actually use the 8 and the 2 and the 3 to start solving for any symmetric expression like this in ABC, which is really kind of cool. But just comparing these expressions here, and let's just double check I have the expression correct. Minus 8x, minus 2x, and a plus 3. Okay, it was a little off. Plus 3, and it's a minus 2x. But comparing these, we can see, okay, so A plus B plus C is equal to 8. AB plus BC plus CA is equal to negative 2. And ABC is equal to negative 3. So, one thing we could do is say, oh, you know what? If I could figure out a little bit more about these smaller roots, I could tell you something about A. So, for example, if I knew that the roots, if B were somehow less than 1 and C were somehow less than 2, I would know that 8 has to be at least, or A has to be at least 5, because otherwise how would you get a sum of 8? So we can do sorts of things like that. And because we're talking about A squared, we might end up using these two as well, or maybe I just wrote them down for fun. We'll see. But, how can we get inequalities like that about B and C? Well, really, I would guess that if we sort of look at small versions or small numbers plugged in to our expression, we might learn a bit more. So we could try some things like x equals 0 into our formula, which would really, really be 0 cubed minus... So 0 is a nice one to start with, because you just get the constant out. So if we were plotting our cubic on a graph, we'd know 0, 3 is a point. Now if I were to do something like 1 and find that 1 is down here at -1 or something, I know that between 0 and 1, my cubic has to cross the axis, so that would be a root, maybe B. And then it might come up again, and there might be C over here, and then A further down over here. So that's the sort of thing, and that's what I'm experimenting with. And I'm starting with 0 because it's a really easy one to calculate. I'll also try 1 and 2. Now, 3 is positive. If 1 turned out to also be positive, there either might be a root somewhere in here, or there might not. There's no real way to tell. But if one of them is positive and the next one I look at is negative, I definitely know there's a root between the two, which is kind of cool. So let's try 1. So 1 cubed minus 8 times 1 squared minus 2 times 1 plus 3. Negative 8, negative 2, that's negative 10. So this is going to be negative 6. So there's a root between 0 and 1. We could try 2, but I'm going to try minus 1. I'm trying to keep the numbers as small as possible. If I tried something with a 2, I'd be talking about 2 squared, and then if I tried 3, then we're looking at 3, sorry, not 2 squared, 2 cubed, and then 3 cubed and 4 cubed, and the numbers are going to get out of control pretty quickly. So I'm just trying to look at small numbers. So minus 1, minus 8, minus 2 times minus 1, so that'll be plus 2. Plus 2, plus 3, so that's minus 4. So at minus 1, we get a minus 4. Then we go up to here to 3. And then we're down to a minus 6 here. So our cubic sort of looks like this. And we have C here and then B here. And A is going to be a bigger root, I suspect. Just because now we can say, alright, B is between 0 and 1. C is between minus 1 and 0. So B plus C is between 1 and minus 1. And therefore, A, which is equal to 8 minus B plus C, we'd have A is between 8 minus negative 1 and 8 minus 1. So A is between 7 and 9. Okay. And we could probably refine this. Plug in 8, x equals 8, and you can actually figure out maybe which side of 8 A is on. And this is nice. It gives us, it sort of narrows down A squared, but not by a heck of a lot. There's a lot of values in there, and you might say, all right, well, couldn't I do the same sort of thing? You know, maybe try 8.1 and 8.2 and 8.3 and you know 7.9 and 7.8, and really narrow down where A is going to be. And I suppose you could if you had enough time on your hands. That's going to be a lot of hunting, and I suspect to be within one of an integer, you might have to narrow it down a lot more than you're comfortable doing without a calculator. I don't even know what would hundredths, knowing A's first couple digits, the 10th digit and the 100th digit, would that help us? Or do I need even more? So, you know, while this is nice, I feel like maybe we should try something else. So I like the idea of using the A plus B plus C equals 8 to figure out A. And then using the information about B and C. But could we do better? Well, we want to talk about A squared. So could I get an expression involving A squared? Well, you can, but you're going to have to keep a B squared and a C squared along for the ride. But we could do something like A plus B plus C squared. And that's A squared plus 2AB plus B squared plus 2BC plus C squared plus 2CA. And these guys seem familiar. So if we subtract off 2 times AB plus BC plus CA, we should be fine. And so that's A plus B plus C, it was 8. And AB plus BC plus CA was negative 2. So that's going to be 64 plus 4, 68. So now I actually have an equation involving A squared and a nice concrete value, an integer. But I've got these B squareds and C squareds. Now, luckily, the B and C are kind of close to 0. So if I square them, they're going to get even closer to 0. And if I could somehow get a restriction on what B squared and C squared could be, I might be able to get A squared within an integer. So, for example, if we somehow knew, let's see, B squared and C squared are at most 1. So if I knew that B squared plus C squared was between 2 and 1.5, for example, then A squared is 68 minus B squared plus C squared, and I'd have A squared is between 66 and 66 and a half. And that would tell me that, oh, A is definitely closer to 66. So if we could do something like that, that would be great. I don't know if we can, but we can certainly try and experiment a little bit. Can we refine what B and C are? Can we get closer? Well, not with integers, but I think we could probably use squares, or not squares, twos, halves. So we could say, all right, now I know B is between 0 and 1, but on what side of a half is it? Well, I'd get a half square, or half cubed, minus 8 1/2 squared, minus 2 1/2 plus 3, 1/8 minus 8 over 4, which is 2, minus 1 plus 3. So this is going to be 1/8. Okay, so looking at our picture, we start up at 3, we go down to 1/8, and then we're all the way down to negative 6. So B is between 1 and a half. And so B squared is between a quarter and 1. You can see this isn't refining things that much. Now we could, so to be within an integer, to be able to say something like A is closest to 65, we would need something like this. So I feel like we shouldn't be settling for a quarter, we should be dealing with a half. So what would give me a half for my B squared? Well, knowing about 1 over root 2, I guess. So we could say something like try x equals 1 over root 2. Oops, wrote 1 over root 3. 1 over root 2, and then you'd have 1 over root 2 to the 3 minus 8 1 over root 2 squared minus 2 times 1 over root 2 plus 3. So we'll get 1 over 2 root 2 minus 4 plus 4, or sorry, minus 4 over 2 root 2 plus 3, and so this will be minus 1 minus 3 over 2 root 2, definitely on the negative side. So now I know B is somewhere in between a half and 1 over root 2, and that means B squared is in this range. And that, incidentally, just keeping track of what we've got so far, B squared plus C squared. We haven't done anything with C squared yet, but we know it's between 1.5 and a quarter. So we're not quite there yet. But really, I don't need that much more from c squared. Right, because remember, c squared is going to be between 0 and 1, because c was between minus 1 and 0. Yeah, so it looks like 67 might be our answer, but maybe it's 68. We need to know a little bit more about c squared. So, what would work? I think a half should do the trick. So let's try x equals negative a half. Negative a half cubed minus 8 negative a half squared minus 2 negative a half plus 3. So that'll be 1 plus 3 at the end there. So 1 plus 3, negative 1/8 minus 4. So that'll be equal to negative 1/8. Well, that's kind of nifty. But, did I screw up an earlier calculation? Oh, this is, yeah, okay, I was wondering why the numbers were wrong. This should be a minus 2. So this is actually 4 minus 2, so 2 minus an eighth, so this is 15/8, which is positive. So looking at what we've got a 3 up here, and then at minus a half, we're somewhere up here. So c is between minus 1 and a half. So c squared is between a quarter and 1, and now b squared plus c squared is between 1 and a half. I didn't even have to go to negative 1 over root 2. That would have been annoying. And 1/2. So a squared, which is 68 minus b squared plus c squared, is between 67 and a half and 66 and a half. 68 minus 1 and a half. So a squared is closest to 67. That was, I would say, not a bad question. I didn't like that we had to check a lot of points here. I'm wondering if there was a clearer way to see that. There might have been a faster way to do the question. There were a lot of points, and I would probably even have done c with negative 1 over root 2, just to be a little safer, a little more cautious there. But, yeah. And I think it probably would have been a little harder to start if you weren't familiar with these symmetric expressions for the roots, which is why taking things like this expression and playing around with them are such a good idea to do. You know, in your off time, and you're preparing for math contests isn't just about doing question after question after question. It's also stopping and saying, hey, this looks interesting. What if I generalize it? Hey, this looks interesting. How can I use this in a different context? What other expressions, for yourself? Try and figure out how to use the 3 expressions we had at the start. Try and use, we'll put them in blue, try and use these expressions here to work out an expression for a cubed plus b cubed plus c cubed. See if you can do it. That would be a great little exercise with these symmetric polynomials. So we'll get rid of this guy right here. In fact, even see if you can answer the related question, what's the closest integer to a cubed? Although that might be kind of really hard to do, but give it a try. Let me know in the comments down below. But that's B4. So up next will be C1. We'll be starting the longer written C part questions. We'll see you for more of the 2013 open paper in the next video.